Hello and welcome again. In this video I'm going to show you how to solve a parallel circuit. So just as a reminder, a parallel circuit, the voltages are the same across the branches, and then the current is going to split. So having this in mind will help you solve this question. So first off, your first step is always to find the REQ. Because we need to know what the total circuit resistance is. Now, when we find REQ of a parallel circuit, we have to do the inverse way. So I'm going to do that: 17 inverse plus 11 inverse plus 12 inverse. It's okay that I switch those numbers since we're adding them. So I'm going to go ahead and do that. I'm going to do 17 inverse plus 11 inverse. So hold on, I'm starting. 17 inverse plus 11 inverse. Hold on. I'm gonna get my real calculator for this one, not my cell phone one. Okay, 17 inverse, 11 inverse. Oh boy. Here we go. I'm better now. 12 inverse, 17 inverse, 11 inverse. My calculator did not like that, so we'll try it again. There we go. Alright, so my REQ, when I solve it completely, becomes 4.29 ohms, like that. That's the REQ. I did the extra step already of taking the inverse of the final answer, just so we're clear with that. So that's our resistance equivalent. So this circuit is like a single resistor, 4.29 ohms, and 60 volts here. So my next step is to find the current total with this relationship, I equals V over R. So V is going to be my 60 volts here, and my R is a 4.29, like that. So 60 divided by 4.29. My current is 13 points. It's 13.99. I mean, we could basically round to 14 here. 14 amps, like that. So my I total, I'm running out of space, sorry, was 14 amps. So those are the first two things you solve for when you solve these questions. So now what I'm going to do, I figured out a better way to do this, so I'm just going to delete this out. There we go. There we go. Okay. So now what I'm going to do is find the current and the voltage across each of the brackets. But remember that V is the same in a parallel circuit. So which means that all of these all have the same voltage, which is 60 volts. Sorry, I ran out of space, but each of those are 60. So the voltage is the same. So there's no solving for that question. But the currents do split, which means I got to find the current for each branch. So I1 will be V1 over R1. I2 will be V2 over R2. And I3 will be V3 over R3. So as you can see, I'm going to calculate these. I wonder if this looks nicer. Let's go back. I'm going to do that. Let's see. I is equal to 60 volts divided by 17 ohms. That's my first one. 60 divided by 17. 3.5 amps. So that's number one. My second one, I is going to equal to 60 volts divided by 12 ohms. So that's going to be 5 amps. And then my last one will be 60 volts divided by 11 ohms. And that's going to give me 5.45 amps. Okay. So like I said, we can always check to make sure things work out. So my total current, if you remember, I total was 14 amps. So I could check here and make sure that it adds up to 14 amps. So I'm going to do that. Let's go ahead and do that. Let's move this up. So my first one was 3.5 amps plus 5 amps plus 5.45 amps. I'm going to add that up. 3.5 plus 5 plus 5.45. 13.95 amps. So that's pretty close. I mean, at that point, I could definitely say that those check out on the this works up and that the current does actually split in our parallel circuit. So that's how you solve all the components of a parallel circuit.